Okay, we're looking at network flows. This is one of the last topics we're studying, and we've been looking at networks already where direction is important and the edges may have distances or times that we might have to consider as part of a question. So there's other sort of networks where we've got the capacity of the edge, like for instance pipes where they might be delivering water along an edge. So copy that down, and when you're ready, flick to the next slide. So here we've got a representation of some nodes A, B, C, D, E. We've got directions and we've got numbers. So the starting node or nodes is called the source, and in the diagram above, A is the source, and we've only got one source. And we've got flow going along the network to the end, and the end is called the sink, and we have two endpoints. So in the diagram above, D and E are both sinks. Okay, copy that down. Okay, we're looking at the same network from the previous page. The flow capacity of an edge. The flow capacity of an edge is the amount of flow that an edge will allow through it. So the inflow of the node is the total of the flows. So the inflow of a node is the total of the flows of all edges leading into the node. So if we're looking at C, we've got 50 and 200 going into the node. So we've got 200 coming from A to C, and we've got 50 coming from B to C. So the inflow of C is 250, whatever those units are. Okay, so we're looking at the same diagram again. So the outflow of a node is the minimum value obtained when you compare the inflow to the sum of the capacities of all edges. Now that is a bit complicated, but for instance, if we look at B, B has an inflow of 100, but if you look at the outflows, we've got an outflow of 130, but because you have to look at the minimum, the outflow of B going out is only 100 because we've only got 100 going in. So despite the fact that we could break it up into whatever numbers we like, we can't deliver 130 when we've only got 100 coming in. So the outflow from B is 100. So this example here is from the exercise that you'll be doing later on. So this is question number 1. And we've got a table, a flow table it's called, and we have to turn it into a diagram. So, and we have to show the directions. So, the first one, we've got A to B is 100, and we've got A to C is 200. Pretty straightforward. But then B also delivers to C an amount 50, so we just put a 50 coming out of B. And then C to D is 250, and D to E is 300. So we've turned a table into a diagram. What I'd like you to do is have a go at the second one, which again is part of your exercise later on, but let's have a go at B. Have a go, draw it up, and when you're ready, we'll have a look at the answer. Okay, and you should have had a go, and the answer to B is down here. It doesn't matter if it's not quite the same in terms of the lines, but we've got R to S, 250, S to T is 200, T to U is 150, but T also goes to V of 100, and then U delivers to V50. So you need to have a diagram, something like that. And you'll be getting some more practice on that later on. So we're looking at question 2 from a later exercise that you'll be doing as well, but just to show you how straightforward they can appear to be. So for node B up here, state the inflow. So the inflow is, there's only one number going into B, so the inflow is just 23. And coming out of B, there's only one thing coming out of B, so the edge capacity out of B is 16. And the outflow from B, we've got 23 going in, but only 16 can come out, so the outflow has to be the smaller number, which is just 16. So you'll be getting plenty of practice of those sort of questions in the exercises, but just another thing, the flow capacity. So the flow capacity of the network is the total flow possible through the entire network. Okay, so we'll have a look at that. Just copy that down, and when you're ready, just flick to the next slide. Okay, so this diagram already has some, I've already made some notes over the top, so we'll go through it. Again, this is an example from the exercise that you'll be doing. And the question's basically saying, find the flow capacity of the entire network. And so again, there's some algorithms or steps that you can follow, but we're going to be looking at it with common sense. So we have, I'll just change colours. So we've got 1,000 possible at the start, and coming out at the end, we've got 200, another 200, a 300, and a 250. So the possible outcome, it might be 950, so we just need to check that that 950 can be delivered. So if you're looking across the top, F is delivering to E200, and it's getting 200 coming in and 200 coming out, so I'm saying that that's okay. Coming out of W, we've got 200, and we've got 200 coming in, so that 200 is also okay. Coming out of D is 300, but we've got 300 going in, so the 300 is possible. And at the end, we've got C coming into the end point, 250. We've got 250 possible, so we've got 250 that can be delivered, so the flow capacity is 950. Even though 1,000 was possible, 950 is all we can deliver. Here's another example that from the exercise that you'll be doing soon. So at the start, we've got 8, 3, and 7. So we've got, coming out of A, we've got 8, 3, and 7. So we're starting with 18. And at the end, we've got 4, 3, and 5, which is 12. So we just have to make sure that 12 can be delivered. So 8 can definitely feed 4, so the 4 is okay. 3 can feed 3, so 3 is okay. 7 can deliver 5, so 5 is okay. So the flow capacity is 12. Here's another example, again, from your exercise that you'll be doing. So I've got the original diagram over here, so I'm not going to clutter it up. So at the start, coming out of A, I've got 12, 7, and 9. So that's 28. So I've got 28 units coming from the start, and at the end, I've got 8, 12, and 4. So theoretically, I might have 24, so we just need to see if 24 can be delivered. If 24 can't, then we don't have the same. So here, I've got 12 needing to feed 8, so 8 can be delivered. So where it says 5 here, because I've already used up 8, I've only got 4 left. Okay? So we can't deliver 5 because if I feed 8, there's only 4 left. Over here, I've got 9. 9 can feed 4, and there's still 5 left over, so it can definitely feed 4. So 4 is not a problem. There's one unit lost, but we've still got the 4 that we need. Okay, we've got 7, and we've got 12 coming out, and I've got the 4 from the top, the 4 from underneath, and I've got 7, so I can deliver 12, which means I can deliver the 8, the 12, and the 4. So the flow capacity is 24. There's no problems there. Okay. Okay, here is the original diagram again. So we just need to see, can we deliver all these amounts at the end, given what we started with. So coming out of Q, I've got 14, but I've only got 12 and 1 feeding into Q here, which means I can't deliver 14, I can only deliver 13. Okay, down here at O, I only need to feed 8 out, and I've got 12 and I've got 1, which is 13, and I've got 2 plus 8 is 10, so I've got 13 going in and 10 going out, so I can definitely deliver the 8. So at the moment, the 13 at the top, the 8. I can feed the 2, and I've got 11. Now, even though I started with 13, I've only lost 1, so I've still got 12 left out of n. So 11 plus 2 is 13, so the 10 is no problems. Okay, so the only one change we've got up there is 13. So I've got 13, I've got 10, I've got 8, which is the 31 units. Okay, and that's the end. You can now have a go at exercise 17C. The ones I want you to focus on really are the flow capacity of the entire network, but there's plenty of examples to just get your idea about turning tables into networks. Thanks a lot.